If you've been anywhere near LinkedIn or YouTube this week, you've already seen the Claude Code story. Gary Marcus, the leaked source code, the 3,167-line file, the hybrid architecture revelation. It's been covered, recapped, and hot-taken approximately 1,000 times in the last 48 hours.
So we're not going to recap it. We're going to use it.
Because here's what most of the coverage missed. The Claude Code story isn't really about Claude Code. It's a thread, and if you pull it, it leads you somewhere most of the takes didn't go. Down through the layers of the stack to a set of infrastructure problems that are going to define this industry for the next decade, and that are almost never discussed in the same breath.
From the team at the Synthetic Daily, it's Monday, April 13th, 2026. We went through about 92 posts and threads this morning. Today we're not summarizing the week. We're following one idea down as far as it goes.
Let's start with what the Claude Code story actually tells us, and it's not what most people said.
Anthropic's Claude Code had its source code leaked this week. Gary Marcus, the NYU cognitive scientist who has spent years arguing that large language models alone aren't enough, wrote a detailed analysis of what's inside. Most people stopped at the headline, Hybrid AI, Symbolic Logic, Marcus vindicated.
But here's the part worth sitting with. The file in question, print.ts, handles pattern matching. Pattern matching is exactly what LLMs are supposed to be good at. It's baked into how transformers work at a fundamental level. And yet when Anthropic's engineers built the most critical component of their coding agent, they didn't trust their own model to do it. They wrote hard-coded conditional logic, 486 explicit branch points, 12 layers of deterministic rules, authored by human engineers.
Marcus has a name for this, neurosymbolic architecture, and that's where most of the coverage stopped. But the more interesting question isn't what Anthropic called it. It's what it implies about everything else they built.
Here's the design principle buried inside that decision. Probabilistic models are extraordinary at generating plausible outputs. They are not reliable at guaranteeing precise ones. And the moment you're building something that has to work every time, not most of the time, every time, you need a different kind of logic underneath.
That's layer one. Reliability requires determinism. You cannot probabilistic your way to a guarantee. And once you accept that, you start asking the same question about every layer below it.
Layer 2 is the protocol layer. And there's a story here this week that almost nobody is framing as infrastructure, even though it's exactly that.
Abdirahman Jama wrote a breakdown on LinkedIn of Anthropic's Model Context Protocol, MCP. His framing is the cleanest we've seen. He calls it the USB-C of AI, which is exactly right and worth unpacking.
Before USB-C, you had proliferating incompatible connectors. Every device had its own plug, its own power spec, its own data transfer protocol. Consumers dealt with the drawer full of cables. Manufacturers loved the lock-in. USB-C came along with one standard and said, "Write to this, it works everywhere."
MCP is attempting to do that for how AI models connect to external tools and data. Right now, if you want an AI agent to talk to Salesforce, someone writes a custom integration. If you want it to talk to your internal database, same thing. 5 enterprise tools means 5 integrations, 5 maintenance burdens, 5 points of failure.
MCP standardizes the interface. A host with a model runs. An MCP client that translates model requests into structured calls. MCP servers, one per external service, that handle the actual connections. Write the server once. It speaks to any model that understands the protocol.
But the stakes go well beyond developer convenience. Jama's point, and it deserves more attention, is that standards like MCP will determine whether we get an interoperable AI ecosystem or a permanent collection of proprietary silos. USB-C succeeded because manufacturers adopted it broadly enough that the standard became self-reinforcing. If MCP reaches that threshold, it becomes invisible infrastructure. If it doesn't, switching AI platforms will always mean rebuilding your integration layer from scratch.
Layer 2. Interoperability requires open standards. You cannot integrate your way out of proprietary lock-in. The protocol layer is where that fight gets decided.
Layer 3 is memory, and this is where the infrastructure story gets personal.
Harrison Chase, the CEO of LangChain, posted this week about what he considers the central battleground in agentic AI. His argument is pointed. Memory is what transforms a language model from a smart tool into something that actually knows you. Your context, your history, your working style. Memory is the difference between an AI that's capable and one that's useful.
Here's the infrastructure problem inside that statement. When you adopt a proprietary agent platform, the kind with the polished interface and the monthly subscription, your agent's memory lives in their infrastructure, their database, their schema, their terms of service.
Which means if you ever want to leave, you don't migrate an account. You start over. Everything the agent accumulated about you stays behind. Chase is pushing for open memory architectures, formats you own, stored in your own infrastructure, portable across tools and platforms.
And this week showed that the demand for persistent memory is crossing from technical discussion into consumer behavior. Network Chuck covered a memory tool built by Mila Jovovich, yes, the actress from the Resident Evil franchise, and pulled 580,000 views doing it. Tom from ICOR demonstrated Claude hooked into Obsidian for long-term knowledge management. 16,000 views. People aren't waiting for the infrastructure debate to resolve. They want the capability now.
The gap Chase is identifying is between wanting persistent memory and understanding who controls it. Consumers are rushing into the former without asking the latter. And the platforms building those polished interfaces are counting on exactly that.
Layer 3. Personalization requires data portability. You cannot learn your way out of someone else's database.
Layer 4 is the one that gets talked about the least and matters the most in the long run. Let's go physical.
Nate Jones flagged something this week that doesn't fit neatly into the usual AI narrative. AI data centers now have to bring their own power. Not as a metaphor. Literally. The electricity grid cannot keep pace with what these facilities consume. And companies are beginning to build dedicated generation capacity alongside their compute infrastructure.
The AI industry is becoming an energy industry, and that reframes the capability question entirely.
We've spent years thinking about AI progress as a software problem. Better architectures, smarter training, more capable models. But the hard ceiling on how much intelligence you can produce is increasingly a question of how many watts you can deliver to how many GPUs, reliably, at scale.
This is the kind of bottleneck that shapes industry structure for decades. The companies that control power generation alongside compute will have a structural advantage that compounds. It's vertical integration, but the thing you're integrating into is the electrical grid.
And the asymmetry here is brutal. You can iterate on a transformer architecture in months. Permitted, constructed, and energized power infrastructure takes years. The software is moving faster than the physical world can respond, which means we are already accumulating a constraint that better models alone will not fix.
Layer 4. Intelligence requires energy. You cannot compute your way out of physics.
There's one more layer we want to name, because it runs across all the others. Call it the discipline layer.
Addy Osmani released an open-source agent skills framework this week. 19 engineering workflows, 7 commands. Alexander Zajac covered it on LinkedIn. What it does is force AI coding agents to follow proper engineering discipline. Spec before code. Test before merge. Measurement before optimization.
The fact that someone had to build this is itself a diagnostic. AI coding agents can generate production-looking code at speed. They cannot, by default, know when to slow down. They'll skip the spec, skip the tests, hand you 500 lines of plausible code with the confidence of an engineer who has never shipped a bug.
Zajac put it precisely. AI-generated code output is the new GitHub green dots. It looks like productivity. It measures nothing useful. The engineer who ships 50 lines they understand beats the one who ships 500 they don't. Osmani's framework is infrastructure for that discipline, guardrails at the agent layer, because the model layer doesn't come with them.
The discipline layer. Good output requires process. You cannot generate your way out of bad architecture.
Let's bring it back to where we started. The Claude Code story got a lot of coverage this week. Most of it landed on the same conclusion. Hybrid AI is real. Marcus was right. The era of pure scaling may be hitting limits.
All of that is true. But the more important read is what that one engineering decision at Anthropic reveals about the stack beneath it.
Reliability requires determinism, and the best coding agent in the world knew it had a hard code, the parts that couldn't afford to be wrong.
Interoperability requires open standards, and the protocol layer is where the next platform wars will actually be decided.
Personalization requires data portability, and consumers are adopting memory tools right now without understanding who holds the keys.
Intelligence requires energy, and the physical infrastructure constraint is already compounding faster than anyone is building to it.
And good output requires process, because agents that can generate anything are not the same as agents that know what's worth generating.
5 layers. 5 versions of the same constraint. The infrastructure isn't just what makes the demos possible. It's what determines which demos survive long enough to matter.
For things to carry out of today.
1. If you're building on AI with hard correctness requirements, you need deterministic logic somewhere in the stack. The fact that Anthropic's own engineers reached for it tells you everything about where probabilistic models have limits.
2. Learn what MCP is, even if you're not a developer. The battle between open standards and proprietary integration layers will be felt in your tools and your data before it shows up in any earnings report.
3. Before you commit to any AI platform that manages agent memory, ask 3 questions. Where does that memory live? What format is it in? And what happens to it when you leave?
And 4. The AI capability ceiling is no longer just a research problem. It's a power generation problem. That constraint moves on a different clock than software. It's worth paying attention to earlier than most people are.
That's the Synthetic Daily for Monday, April 13th. All sources and links are on the website.
See you tomorrow.
Thank you.